The Apollo era. When I was 10 years old, my dad brought home 8mm footage from NASA, and he would project it on the wall of my bedroom. And it was the view of this strange triangular window of the lunar module and this moonscape sort of rising up, and there were no trees, there's no vegetation, there's no rubble or walls, and it's obviously an alien world. And I imagined myself in that lunar module descending down to an alien moon, and that hooked me. My name is Cameron Smith. I'm building a DIY spacesuit. I'm excited by being a very tiny part of the evolutionary future of our species, which is space settlement. This is one little piece of the puzzle that I can contribute. The Apollo Moon program, that's 400,000 engineers across the United States. No one of them could have built the whole moon program. Every single one, though, contributed a tiny piece. So what part can I play in space settlement? A little bit of advance maybe in spacesuits. I'm very lucky to have volunteers who are taking their own time from their lives. They build pieces of equipment. They help out in the tests.
Communications gear and thermal probe in bag.
Comms and the thermal probe are through the bag. My dream when I was 10, of course, was to go into NASA. Comm check 1, 2, comm check 1, 2. At that time, the path to NASA was through military aviation. So I thought, all right, I'll fly for the Navy. And I started looking into it, and I discovered that you had to have perfect vision to fly in the front seat, to be the pilot. And my vision wasn't exactly perfect, so I had to pick a different path. But I was able to learn about evolution and now apply evolutionary principles to adaptation to space. Once I decided that I would try to contribute to human space settlement by building cheaper and lighter spacesuits, I thought I would look at the history of spacesuits. So I looked into the 1930s when they were building pressure suits for very high altitude balloon flight. And I saw that these were made from very crude materials, canvas painted with rubber to make it gas tight, pigskin gloves, basically a bucket and a glass faceplate for a helmet. Some of them got to 50, 60,000 feet in balloons. None of them were killed directly by this. And I thought, if they could do this in the 1930s, with the materials available in the 1930s, surely 70, almost 100 years later, I could do it today. There are four main layers to pretty much any spacesuit. The first one is a thermal garment, and this either cools or warms you depending on the conditions. The second layer is a gas-tight pressure barrier. This holds a bubble of pressure around the body and prevents decompression sickness. Third layer is coverall. It gives you pockets to carry things in. It allows you to attach hardware. It's also protection against abrasion and punctures of the pressure bladder. The fourth layer is really a set of components that are attached. The gloves, the helmet, there are boots, and then there are a whole set of fittings, ports where gas, fluids, and electrical power go in and out of the suit, giving us communications, control of the carbon dioxide level inside. So my paradigm for the spacesuit is to get away from the holy relic, to get away from the idea that it's this super special thing that only a few people can touch and you need a very experienced technician to fix it. My paradigm is the Ford pickup truck. I want the Ford pickup truck of spacesuits. Cheap, durable, highly reliable, and I can fix it myself. I wonder how this will take seaming.
Yeah, I wonder how it'll sew.
Compared to the more common materials that I use are hose clamps. We use those. You use them in your car to clamp hoses onto pipes. We use them for pressure closures. The wiring inside the spacesuit is not much more complicated than in an old pickup truck. We do a few things. We insulate everything so you can't get a spark because we breathe 100% oxygen, so it'd blow up. But really, we're using 12 or 20 gauge wire, just like you buy at the hardware store. We started to make it more comfortable and more reasonable to actually be in these. We used to have a really sort of atomic wedgie effect. The whole suit would pull up into your crotch, and it was really bad. Okay, we cut the suit so that now that's gone away. Ready? Yeah. 1, 2, 3. Beauty. Once a suit is assembled, one of the first tests is simply, does it maintain its essential pressure? So we put a person into it.
Across the suit, and mobility is good.
We run the coolant, we run the communication system, we just check it all out. It used to be a really special thing getting in, you know, once a month you get into this suit and it's really special. Now it's almost routine. Once you're inside though, it's still an adventure every time. All 5 of your senses are engaged. What you're breathing, the taste and the odor is different because it's coming from a canister of oxygen. The sounds are strange. You hear pumps, you hear hissing, you hear people talking on the radio, not just the normal voice.
And in a matter of minutes, I would be blinded.
We like to take the suits outside and put them into sort of real-world gritty conditions. So we'll go down to the river and we'll get in the water and we'll see, you know, is it leaking? Is it able to sustain, you know, again, if we crash land on Earth in water and we need to climb into our survival raft. We've also tested in altitude chambers, and they pump the pressure down and you simulate high altitudes, and the spacesuit must work at that time, and it has. But even that's a sterile, controlled environment. And so now we're going to start flying in the spacesuit to high altitudes in my balloon, and we'll slowly go to higher and higher altitudes, and the natural world will be our pressure chamber. I've been working on this since 2008. My first drawing of a concept of flying in a balloon in a suit that I'm wearing myself, that I built myself. The date on that is 2008. And then I spent a year doing research, and then I started building things, so roughly 10 years. I don't know how much I've spent. I've spent everything that is available to me. Probably less than $30,000 by this point. And that's, you know, that's why I work, is to have money for adventures and projects like this. My plan is to make it all open source. So I'll take all of our plans, everything that we've done, and that goes online, and people can go there and download it, and I hope that people will then make improvements on it. The more people you have making iterations on it, the more likely one person is going to have a great design, and that will be maybe, you know, the next fundamental design for spacesuits. I hope a lot of spacesuit designs are iterated, and then a few will result from this and they make spacesuit design better. Thank you.